Example 9. One way to save on energy costs is to have an airtight house. One measure of airtightness is the ACH, air changes per hour, of a house using a blower door test. The ACH is given by the formula ACH equals 60 times L divided by V, where L is the air leakage in cubic feet per minute, CFMs, and V is the volume of the house in cubic feet. Suppose that a blower door test resulted in an air leakage reading of 539 CFMs in a house with a volume of 22,200. Calculate the ACH to the nearest hundredth. So notice that we're given the following. First, the formula for ACH, and look, that's what they ask us to find. Then they give us an air leakage of 539 CFMs. Okay, that's what L is. L is the air leakage, so that's L. And then they give us a volume of the house of 22,000 cubic feet. So our ACH is equal to 60 times 539, that's the L for air leakage, divided by V, the volume of the house, 22,200 cubic feet. So order of operations, we'll do this multiplication in the numerator first. So 60 times 539 is 32,340. We're going to divide that by 22,200, and we get 1.47 to the nearest hundredth, which is two places. So our answer is 1.47. So we have to identify the parts of the formula, especially when there's one we're not familiar with the parts, and then substitute them in and find the value. Example 10. The theoretic airflow of an engine is given by T equals D times S over 3456, where D is the displacement in cubic inches, S is the engine speed in RPMs, revolutions per minute. The theoretic airflow will be in cubic feet per minute, so that's what we're asked to find. We're going to find the theoretic airflow if the displacement is 181 cubic inches and the engine speed is 3,500 RPMs. So our T, which is our theoretic airflow, is our displacement, 181, times S, the speed of the engine, 3,500. All of that is divided by 3,456. So again, we'll do the numerator multiplication first. 181 times 3,500, 633,500. Divide that by 3,456, 3,456. And we get a decimal, so we look, nearest tenth means one place. So 183.30 is going to be 183.3. Example 11. A tree is given a numerical rating R using the following formula. R is C plus H plus 1/4 S. C is the circumference of the tree in inches. H is the height, and S is the average crown spread. And so what they're talking about is you got a tree like this, right? And the crown spread would be from here to here. That's how far its limbs reach out, its branches, how far those branches reach out. So what do we know here? We know we've got to find R, our tree rating. we're given a circumference, that's C, of 495. We're given a height of 97 feet. And the crown spread is 98, so 1/4 times 98. So we're going to add 495 plus 497, plus 97 plus 1/4 of 98. So first I'm going to do 98 divided by 1/4. So 98 divided by 4 is 24.5, and now I'll add all that together. So 495 plus 97 plus 24.5 is 616.5 to the nearest tenth. Example 12. A repair service charges $25 for a house call. That's a flat fee. And an additional $40 per hour. Okay. The formula is total equals 25 plus 40 per hour. So if the bill was 165, so that's the total is 165. How many hours, so hours is what's missing, our H, of actual labor was there. So this is one where we have to actually solve for our H. So the first thing we would do is undo this addition by subtracting to both sides. That gives me 140 is 40H. And now the opposite of multiplication is division. Divide by 40. 140 divided by 40 gives us H is 3.5. So 3.5 hours is the total number of hours of labor. Example 13. A plumber's total bill can be calculated using the formula A equals RT plus M. R is his hourly rate, T is the total time in hours, and M is the cost of the materials. A plumber bids, look, an amount for the bill of $28.30. And materials are $111.18. And the rate is 64. How many hours are they expecting to do the job? So remember this time that A is the total bill, so $28.30. Okay, and R is the hourly rate, so that's 64. And T is what we don't know, the time this time, but we do know materials, 11.18. And so that's supposed to be an equal right here. Let me fix that. So it's going to be 28.30 equals 64 times the time plus the materials, 11.18. We're going to subtract that 11.18. We're solving again this time. So 28.30 minus 11.18 is 1712 is 64T. And now since that's multiplication, we have to divide by 64. Both sides. 1712 divided by 64 is 26.75. So he expects to spend 26.75 hours on the job. Example 14. A certain car generates 536 horsepower at 7,000 RPMs. Use the following formula to solve for the torque created at this engine speed. So horsepower is torque times engine speed divided by 5252. So we know our horsepower, 536, and we know our engine speed, 7,000. What we don't know is this torque. So our horsepower, 536, is our torque. We'll just call it T, times our engine speed, 7,000, divided by 5252. So the best thing to do here would be to go ahead and clear out this division, 5252, by multiplying it on both sides. Then we get 5252 times 536 is 281072. And then over here I've got 7,000 T. And you can put that T times 7,000 or 7,000 times T. In either case, I need to divide by 7,000 because it's being multiplied. So 2,815,072 divided by 7,000 gives me about 402.15. They say round it to the nearest whole number. We'll go with 402 for that. Example 15. The pressure P in pounds per square inch, or PSI, of a submerged body in wastewater is given by the formula P equals 0.520 D plus 14.7, where D is the depth. At what depth is the pressure? 32. So look, they're giving me P, the pressure. They're giving me D, the depth. And they're asking me to find, no, they're giving me P, the pressure, and that's all. And they're asking me to find D, the depth. So my pressure is 32, 0.520 D plus 14.7. So the first thing I need to do is subtract away this 14.7 from both sides. That gives me 32 minus 14.7. 17.3 equals 0.520 D. Now divide by 0.520. And so that gives me 17.3 divided by 0.520 gives me, rounded to the nearest tenth, that's about 33.269. To one place, it would be 33.3 feet. So the pressure at 32 psi is at a depth of about 33.3 feet.